Okay, I'm going to do these as fast as possible and try to get through as many as possible. Now, if I've got square root of 14 times square root of 21, what I can do is put them together under one radical, but let me prime factor each before I rewrite them. 14 is 2 times 7, and 21 is 7 times 3, so you can see that you got 2 7s. That means you can pull a 7 out front, or the square root of 49 is 7. And 2 and 3 don't have partners, so you can say, okay, well, they're left inside. Go ahead and multiply. 2 times 3 is 6. So that's what you would do on 22. On 23, you have a fraction, 242 over the square root of 2. And if you remember what the radical rules say is if you've got a fraction, you could put, and you've got the same root on them, you can put them under one radical and do this. Now, the benefit of doing that is if you reduce the fraction, 2 goes into 242, that would be 121 times. And oh, the square root of 121 is 11. So a lot of times when you have fractions, if you just put them under one radical and simplify them, you can, go ahead and reduce them, and it works out nicely. 24, the point on 24. Again, you can pause the video if you need to. I'm just trying to get as many on a video as I can because it's hard to. It just takes so much time. There's only so much time on video. All right, so now on things like this, the parts that are outside the radical we can multiply. So I can say 4 times 6 is 24, and that goes on the outside of the radical. And then on the inside of the radical, we could combine those things. We have a 5 and a 2. So we could write them under one radical and go ahead and multiply them. Well, there's no perfect squares inside that radical. Those are actually prime numbers. So my answer would be 24 square roots of 10, and I'd be done with that. 25, just a caution on that. 3 square roots of 7 squared. You got to square the 3, and you got to square the square root of 7. 3 squared is 9. The square root of 7 squared would just be 7. You're kind of taking the square root but turning right around and square it, so that would be a 7. So 9 times 7 would be 63. Let me go to a new page. Okay, this is some similar ideas that we've had in previous problems. You can reduce the parts on the outside. 4 goes into 1, 4, and 4 goes into 12 3 times. Now, so I've got a 3. And then you got a radical, you got a square root on top and a square root on the bottom, so I could just go ahead and put those two things under one radical. And if I reduce 15 over 3 inside the radical, that's just 5, so that would be my final answer there. On number 27, you have 5 minus the square root of 2, and then you're adding 5 plus the square root of 2. So basically, you really don't need these parentheses because you're just adding a bunch of terms up. 5 and 5. Those are whole numbers, so we could add those together and get 10. Now, on the square root part, a minus square root of 2 and a plus square root of 2 would actually add up to 0. So you'd have 10 plus 0 is 10 for that one. Now, the next problem looks a lot like it, but it's very different. 5 minus the square root of 2 times 5 plus the square root of 2. Now, you could multiply this out, but if you look, this is a minus b, a plus b. This is a difference of 2 squares, and you need to remember that from Algebra 1. It doesn't go away just because you're in geometry. So if you remember the quick way, you could multiply this all out, but what ends up happening is that the pattern for this is if you have a minus b, a plus b, it's the first thing squared minus the second thing squared. So that would be 5 squared minus the square root of 2, the whole thing squared. Well, 5 squared, I'll come down here, is 25. And then I'm going to subtract. The square root of 2 squared would just be 2. So 25 minus 2 is 23. Okay, this is hard to read, but that's 29 there. What I'm going to do here is I'm going to, first of all, I'm going to distribute this. So that's the square root of 3 times the square root of 27, which I could have gone ahead and put them under one radical. I'll do that in the next step. And then plus the square root of 3. All right, so what I'm going to do is put square root of 3 times square root of 27 under one radical. Let me go ahead and prime factor 27. 27 is 9 times 3, and if I prime factor 9, that's 3 times 3 times 3, plus, then I've got that other square root of 3. Now, if you look what's inside the radical, you got a set of 3's there that can come out, and then another set of 3's that can come out. Now, if you multiply 3 times 3 times 3 times 3, it's 81. The square root of 81 is going to be 9. 3 times 3 is actually 9, isn't it? So you could have looked at it that way as well. 3 times 3 is 9, plus the square root of 3, and that's done. Now, 30 looks a lot like 29, but you're not multiplying anymore. And so, really, you don't need those parentheses. You're just adding a bunch of stuff together. So it's the square root of 3 plus. Now, the square root of 27, let's prime factor 27. We actually just did that in the problem above. That's 3 times 3 times 3, and then I got a plus 1. All right, so I've got that square root of 3. There's a pair of 3's under the radical. Basically, 3 times 3 is 9, and the square root of 9 would be 3, or you've got a pair. You can bring it out as one couple. And so I've got a square root of 3 left that didn't have anybody to team up with. And now we've got 1 that we got to put on the end. Now, you can actually combine these terms, because this is like 1 square root of 3 plus 3 square roots of 3 is actually 4 square roots of 3. And then I got this plus 1 here that I can't really combine with that. So I could stop there. Okay, on number 31, they're kind of trying to fake you out a little bit. They put all these parentheses in here, but you're just adding a bunch of stuff, right? There's no multiplying going on here. A lot of times when we see parentheses, we just start assuming that it's multiplication, and here it's really not. We could take off every single one of those parentheses. So if you look, we've got some like terms. We've got a square root of x plus another square root of x. Well, if I have one square root of x, and somebody gives me another square root of x, I have actually 2 of those square roots of x. So those two could combine that way, because remember, I'm just adding, and it's kind of like they're like terms. They really are like terms. Let's look at let's look at the square roots of y. I've got 1 square root of y, and somebody gives me another square root of y, so I have 2 square roots of y. And so this would be my answer here for 31. 33 takes, it's a little bit more complicated. We've got to be careful. A lot of people look at this and want to say, oh, that's just square root of x squared plus square root of y squared. No, not really. It's not, because this means I got 2 copies of those things. Okay, so I'm going to write them down. And now I'm going to distribute, or sometimes people call this FOIL, so I'll do it one thing at a time. Square root of x times square root of x, that would be square root of x times x. Isn't that the square root of x squared? Or you could say, well, there's 2 copies of them, so that would end up being just x, okay? So let's see, let's do the next one. Square root of x times square root of y. Now, square root of x times square root of y, I could actually put those together under one radical since I'm multiplying and they're just radicals. All right, now I'll do this. Now, square root of y times square root of x is the same thing as square root of x times square root of y. The commutative property says I could look at it the same way. And, I could switch the order. So that's another square root of xy. And I see that I've got 2 square roots of xy, so we'll be able to do something with those in a minute. And then the square root of y times the square root of y would be the square root of y times y. I could put them under one radical. Well, if you look, there's a pair of y's. That's really y squared. The square root of y squared is really just y. So now if I want to kind of clean this up a little bit, I have my x, I have my y down here, and I got 1 square root of xy, and somebody gives me another square root of xy, so that's 2 square roots of xy. And you're done. Actually, that was 32. I think I wrote 33, but there isn't even a 33. This is 32.